A quadratic equation is an equation where the highest power is 2. Now, I want to spiral a bit. We're going to have an official lecture video on the graphs of quadratics, but I want to start introducing you some of the ideas. So if we were to throw a football through the air, it would probably follow some kind of a pattern like this to the point where it's caught. This kind of a shape is called a parabola. So in this case, the parabola will look something like this. It could also be upside down, which is more typical. But these are the general shapes of graphs for a quadratic. So this right here is a quadratic. You'll notice that it has a second power. And if we were to distribute that, right? So that means that it's a plus b times a plus b. We would get a squared plus ab plus b squared. And of course, these two combine to get that 2ab right there. This is also a quadratic. Now, our biggest focus of study with quadratics is solving them. In other words, getting the x all by itself. And so we discuss here briefly what it means to solve an equation. Let's look at problem 2. So in order to solve this equation, we want to get the x on one side. Now, this is not a quadratic. How do we know it's not a quadratic? It doesn't have a power of 2. See how these had little powers of 2's? Those were quadratics. But to solve this pre-algebra problem, we want to move everything to the same side. So I'm going to move this 2x over here. And then we move this 3 over to the other side. And then we take this result, and we want it to be equal to x, so I divide both sides by 3. And we get the solution. This is what it means to solve for an equation. When you get x all by itself. So you get x equals blank, then that means we solve the equation. Some equations don't have a solution. And so we would say that there is no solution. You may have encountered this before in previous classes, but in Algebra 2, it becomes more of a topic of conversation. So here we have a couple of things to consider. You may have a hard time figuring out what to do with this x on the top and then the x on the bottom. So if we could multiply both the top, both sides by x plus 2, you'll see that this whole term cancels out. So this is what your teachers in the past maybe called quote-unquote cross multiplying. Okay, and so we have x plus 1 is equal to 1x plus 2. This means I have to distribute the 1 to everybody, which doesn't really do much for us. Now look what happens if I get solve for x, right? I'm going to subtract x from both sides. But if I do that, they're gone. And I'm left with 1 is equal to 2. Which is not true. Like, if you have one pizza and I have 2 pizzas, do we have the same amount of pizza? Yeah. Or I should say the same quantity of pizza, right? It's not quite true. At least with our number system. So if the variables are gone, right? The x's cancel out and the numbers aren't equal, then we say that there's no solution. Okay. Now, I will kind of give you a hint at some things. We know that, and this might be a left column idea you might want to remind yourself of, but there's this thing, right? 0 divided by 1 versus 1 divided by 0. And you might need to pause and pull out a calculator to see what's going on. So try it. Here's 0 divided by 1. It's 0. I bet you're surprised. Let's try 1 divided by 0. Oh, we got What the heck is It's what your teachers have been telling you all this time, that you can't divide by 0, right? We formally call this undefined. Undefined just means it's not part of the rules, so we don't quite know what to do with it. Undefined means we're playing basketball, but somebody starts playing with a football for the basketball. That's just not defined in the rules. Or you're playing Uno, but somebody pulls out a queen, and you're like, that's not even, I don't even know what to do about it, right? So that's what undefined means. It means it's not defined. It's not a part of the game. It's not a part of the rules. So we have beef with things that are undefined in math, right? And so we look at this problem right here, and if we simply consider the bottom, we can't let the denominator become 0. If the denominator becomes 0, then it's undefined. So what would make this equal 0? Well, we could just take the bottom, for example, and set it equal to 0. This is something you're going to do a lot in pre-calculus and in calculus. And it's very simple. It's basic algebra. But if we take the denominator and set it equal to 0 and solve, right? We solve for an equation like we've been talking about. We get that x equals -2. Now, we're not saying that this is the solution to this problem. We're saying that if x equals -2, then the denominator becomes 0, and the problem becomes undefined. So we know for a fact that, well, we've already shown that this problem has no solution. But when we get to deeper mathematics, we're interested in what makes it go no solution, or what makes it go 0. Okay? So we could still have a basketball game going on. We could still have all the right amount of players in the right positions with the right outfits in the right venue. And if all of a sudden somebody brings a football and a basketball, well, we could be like, hey, the football, that's undefined, but we'll take the basketball. So we can still play the game, and the game can go on. We just have to ignore one little thing about the whole situation. No football, right? We're not going to play basketball with the football. Okay? So be aware that in mathematics, there are no solutions all across the board, but sometimes some problems just have an issue with one little detail that would make it undefined. So keep that in mind. We kind of have that situation for problem 4, and I don't want to quite solve for problem 4 all the way because it might get a little tricky, but sometimes there may not be a solution because the denominator becomes 0. Okay, so for example, if we look at the denominator here, right, we don't care about the numerator. We already saw the calculator will divide 0 by anything, but it won't do what anything divided by 0. So if we look at this and set it equal to 0 and solve for it, we know that if x equals 3, then the denominator becomes 0, and it's very much possible that this could become undefined. Now I'm saying possible because I know a little bit about mathematics. And so this particular problem, we can do the hokey pokey and some interesting things will happen. For example, if you would recall, and we're going to really practice this a lot more in detail later, but this is called the difference of squares. And it factors out to become x plus 3, x minus 3. Now in the bottom, we already have an x minus 3. And then to the right, I have the x plus 3. So all I'm doing is taking this numerator and factoring it to become these two guys. Now, it's actually convenient because they cancel out. It's the same package deal. So I'm left with x plus 3 on the left, x plus 3 on the right. So these are identical. And if you wanted to solve for x, I mean, we could subtract x from both sides, and they would both disappear. And so we're left with 3 equals 3, which is very much true. So this is what we called in Algebra 1 and in pre-algebra, infinitely many solutions, right? In other words, it doesn't matter what you plug in for x, you're going to get the same answer all across the board for this problem. Okay? So in this case, it's a bit of a trick question, right? For what values is there no solution? Well, we thought that if x is 3, it's going to be undefined, but there's this little tricky thing where if we factor, we can remove that singularity or that special case. Okay. Now this is in preparation for deeper mathematics in the future, but I just want you to kind of start getting a feel for some things. Okay, I'm showing you a few things here. This, for example, right here is a quadratic, right? It has a second power. Summary: when do you know if you are done solving for an equation?